What's up, 7th grade? Mr. Agnos here. This video is for homework 8-2. I actually really like this 8-2 topic. It really hits on something that I've mentioned many times in class, is that when you're in math class, you're not learning like a series of tricks, and that you're going to use in some future job or something. What you're learning is you're learning how to speak a language. Okay, math is a language, and you're learning how to speak that language, so that when you go into higher education and when you go into the workplace, you are fluent in mathematics. So when you see graphs and charts and numbers and people present you with information, you can use the mathematical skills of logic and reasoning, right, to figure out, is this true, is this not true, and whatnot. Math is a language, right, and you guys are learning how to speak it. So this topic really hits on that. Basically, what we have to do in this topic is read something that's written in English and translate it into a mathematical equation. We have to say the same thing in math, right? And then ultimately, we do start solving these equations. But again, for today, it's really about, hey, can I read something that's written in English, translate it into math? Because once it's in math, then I can actually work with it and use it. So I'm going to do 3 problems just to kind of give you an idea of how this works. I'll start with number 1. Last night, 3 friends went out to dinner at a restaurant. That'd be nice. This is obviously pre-COVID times, right? 3 friends, so that's a piece of information, so I'm going to underline that. They split the bill evenly. They split the bill evenly. As soon as I read that, I think divide by 3, right? There's something, and we're going to divide it by 3, right? Each friend paid $12.50. So that comes after the split. Right? That comes after the split. So to me, this kind of says, hey, something is going to equal $12.50. So again, I'm just going through here. I'm just picking out pieces of information, and I'm kind of like preparing myself. All right, we're going to divide something by 3 because there's 3 friends. They ended up each paying $12.50, so that's going to be like an equals $12.50. If B represents the total bill in dollars, so that's the variable they want us to use for the total bill. B is the total bill. What equation could you use to find the value of B? And then they give us a whole bunch of equations here. All right, so literally imagine that you're sitting at the table and the waiter walks over and hands you the bill. Boom, there it is, right? There's the bill. And so you guys stare at it, you calculate the tip, and then you say, okay, everybody owes this much. Well, what you did to figure out how much everybody owed was you took whatever the bill is and you divided it by 3, right? So if the bill was $60, including the tip and all that, you said, well, let's just divide that by 3 and we're each going to pay 20, right? So the bill comes. You guys do a little quick math. You divide the bill by 3, and we know that each friend ended up paying $12.50. All right, so we took the bill, we divided it by 3, and everyone ended up paying $12.50. All right, so there's my equation, right? This is the total bill. This is the number of friends. And this is the amount each friend paid. So I'll say each paid. There we go. Each paid. So now I look through my choices, and there it is, choice D, right there. So that's the general idea, is we're going to take a statement that's written there in English, and we're going to turn it into a mathematical equation. Now, this question doesn't ask me to do it, but I could go ahead and solve this and figure out, well, what is the total bill, right? Since B is being divided by 3, we would multiply each side by 3, right? Because if each friend paid $12.50, and there's 3 friends, well, you would say $12.50 times 3 gives me the total bill, right? That is coming in future assignments. Okay, I'm going to go on and do number 3. All right, number 3 takes an interesting approach here. They kind of provide you with like an intermediate, a middle step. They give you a story in English, and then they write a mathematical equation still using English. And what they're trying to do is to get you to see the connection, right? That this is kind of like you could consider all this stuff right here as a middle step, right? And we're just going to, if there was another step after this, we would just replace each of these terms with a variable or a number or something. But here they're saying, hey, here's how you set it up as a mathematical equation, right? And then we can use numbers and symbols to make it even more concise. Concise means short. A farmer ships pears in crates that weigh 6.5 pounds each when empty. So I'm going to underline that. Crates that weigh 6.4 pounds each when empty. Each pear weighs 0.32 pounds. When I hear each pear weighs 0.32 pounds, I already start thinking, okay, we're gonna have to multiply here, right? If I have 0.32 per pear, and then maybe x is like the number of pears. Again, except we're not going to use a variable here. And if you look at these, you can see it says number of pairs, number of pairs, right? So that's what x would represent, right? So I'll just say 0.32, I'll write it out, times the number of pairs. So I'm going to be looking for an equation for sure that multiplies 0.32 times the number of pears. I'm not going to lie, I'm not a big pear fan. I much prefer an apple. I mean, pears are okay, but the total weight of a crate filled with pears is 60.8 pounds. All right, notice it says a crate. A crate, that means one crate is 60.8 pounds. Write a word equation you could use to find the number of pears packed in each crate. Okay, so let's think about this. We know the total weight is 60.8. Anytime you see total, right, that usually is going to be the equals, right, equals the total, right? So total weight is 60.8. So something is going to equal 60.8. But again, we're not using numbers, we're using total weight. So we know that the total weight, well, let's think about here. I have a crate and then I have pears. So I need the weight of the crate, right? So the weight of the crate is 6.4 pounds. Again, they don't want the actual numbers, but I need to add the weight of the crate plus we're going to have the weight of the pears, right? We're going to have the weight of the pears. Well, we don't know how many, we have more than one pear, right? So that's where my 0.32 times the number of pears comes in. So how would I write this in complete English? Notice we have the weight of one pear times the number of pears, right? So that's what I'm looking for. But I'm also looking for this plus, because I have the weight of the crate plus the weight of a pear, which is this number, times the number of pears, right? So I would have the weight of a pear times the number of pairs. And remember, order times number of pairs. Remember, order of operations says that, hey, we're gonna do this first, right? So we're gonna find how much the pairs weigh. That's this little pink part. Add the weight of the crate, and that will give us our total weight. So let's look through here. They all start with total weight, and then this one is multiplying everything. This one has the plus that we're looking for. The weight of the crate plus the weight of one pear times the number of pairs. Boom, that's our answer. You can see here they're subtracting. Here they're multiplying the weight of the crate times the weight of one pear. That makes no sense. And here they're just adding everything. That makes no sense either. So in this case, it would be choice B. Now, if I was going to write this, purely mathematically, we could have some variables, right? Like we could say that, the total weight would be like Y is equal to the weight of the crate would be 6.4 plus 0.32 times the number of pairs, which is maybe X. And you can see, like, this is much more concise than this, right? So that's why I'm saying this is kind of a middle step, but they're just trying to get you to think about that, hey, each of these numbers and letters represent something, right? So this is why it's really useful to write things in math, because this is short, it's concise, and now we can use it, right? We can figure out, well, how much does a crate weigh with one pair in it, or two pairs in it, or five pairs in it, right? How does all this change if I have 2 crates or 3 crates, right? We can use this equation to figure all that stuff out. All right, the last question I'm going to go over is number 11. Again, these videos aren't meant to tell you everything. They're just a little shove to get you started. All right, I chose this question because it has fractions in it, but luckily they allow us to do a little estimating here, and we're actually not going to need those fractions, but I know kids freak out when they see fractions. A rectangle has a length of 3 7/8 inches and an area of 4 15/16 square inches. I'm going to stop right there, and let's just review real quick that to find the area of a rectangle is length times width. All right? Round these measurements to the nearest integer. Integer is a positive or negative whole number. Since these are both positive, we're just going to round them to the nearest whole number. So let's just do that right now. It says round these to the nearest integer, think whole number. Well, 3 7/8, that is almost 4. 4 15/16, that is almost 5. Okay, and this is the area, and this is the length. Then use those results to write an equation relating the rectangle's length and width to its area. So we know the area is about 5, so I just put a 5 here. We know the length is about 4, so I put a 4 here. And the only thing we don't know is the width, so we'll use that for W. So I get 4W is equal to 5. I look over here, boom, there it is. You'll notice that mine is sort of the mirror image. If two things are equal, right, it doesn't matter how you flip them, right? I could say 2 times 5 is equal to 10, right? Or I could say 10 is equal to 2 times 5. It didn't matter that I flipped things, right? These are both true. So same thing here. These are actually identical. So that question actually turned out to be pretty straightforward. So don't let those fractions mess you up. Okay, I actually think this is a really, I'm going to use the word fun. I don't know if you guys find it as fun as I do. But it really gets at the point of math as a language, and I got to be able to translate things from English into math, because math allows us to write them much more concisely and then to actually do stuff with it. And solve problems and figure things out and make predictions and whatnot. All right, so this video was meant to help get you started. Make sure to ask lots of questions in class, and I'll see you guys soon.